In section 8.5, we look at quadratic and other nonlinear inequalities. And so let's consider an example where we have x squared plus 3x minus 10 is greater than or equal to 0. Well, the way you solve a quadratic inequality is very similar to the way that you solve a quadratic equation. So the first thing I'm going to do here is I'm going to factor the left-hand side, which we should know is x plus 5 times x minus 2, and we want to know when is this greater than or equal to 0. So a key point I want to make here is that you need to have 0 on the other side, just like you do with a quadratic equation. So now we know for the equal to part of this inequality, we know that x would be equal to negative 5 or x would be equal to negative 2. These are the solutions to the equation, but when you're solving an inequality, we call these the critical numbers. Now the next step is we're going to go to a number line and we're going to put these two critical numbers on this number line. Now the solution for the greater than portion of this inequality is going to be one or more of these three intervals. So what we need to do here is we need to divide up this number line into those three intervals, and we need to pick test points for each one of these intervals. So for example, when we are on the interval here, this is all numbers that are less than negative 5. One test point that we could pick would be x equals negative 10. You don't have to choose negative 10. You could pick any number that is less than negative 5. On the interval between negative 5 and positive 2, I will choose the number x equals 0 to be our test point. And on the interval where x is greater than 2, I'm going to choose x equals positive 10 to be our test point. Now what we need to do is plug in each one of these test numbers into our inequality here to see if it is true or if it is false. So for example, when x equals negative 10, if you plug this in, you get negative 10 plus 5 times negative 10 minus 2 is greater than or equal to 0. And we are testing this, so I'll put a question mark here. And all we have to do now is the math. So negative 10 plus 5 is negative 5. Negative 10 minus 2 is negative 12. And the question is whether or not this is greater than or equal to 0. Well, yes it is, because a negative number times a negative number is a positive number, and a positive number is always greater than 0. So negative 5 times negative 12 is a positive 60, but it doesn't matter what the actual number is. It only matters if it is positive or if it is negative. Okay, so this is true. That means that negative 10 is a solution to this inequality, but that means that any number on this interval would be a solution. So we're going to shade in all numbers on this interval. These are all solutions to the inequality. Now we're going to repeat that process for the next test number, which is x equals 0. If you plug in x equals 0, you get 0 plus 5 times 0 minus 2 is greater than or equal to 0. And then we do the math. 0 plus 5 is 5. 0 minus 2 is negative 2. Is this greater than or equal to 0? Well, no, this is false. And it's false because 5 times negative 2 is negative 10. And negative 10 is not greater than 0. So that means that 0 fails to satisfy this inequality. And so we will not be shading in any number on this interval. Finally, we're going to check x equals positive 10. When you plug in positive 10, you get 10 plus 5 times 10 minus 2 is greater than or equal to 0. And this says 15 times 8 is greater than or equal to 0. And this is, once again, true because 15 times 8 is a positive number, and a positive number is larger than 0. So that means that x equals 10 is a solution. And since that represented all numbers in this interval, we are going to shade in the whole interval. So now we're going to put down our final solution here. And your final solution should be written in interval notation. And so we need to represent all the numbers less than or equal to negative 5, plus all the numbers greater than or equal to positive 2. And in interval notation, this is how we write that. And a quick note here, we are including negative 5 and we are including positive 2 because in the original problem we had an equal sign, and equals means you include. Okay, let's try a few more. So for our next problem, it's very similar. First thing we need to do here is we need to get 0 on the right-hand side. So I'm going to add 8 to both sides, and that will give us x squared minus 6x plus 8 is less than 0. Once we have it less than 0, we can then factor, and the factorization here is relatively straightforward. And once we have it factored, we can identify our critical numbers. Now again, the critical numbers are the numbers that make each one of these factors equal to 0. So in this case, the critical number is going to be x equals 2, because 2 minus 2 is 0, and x equals 4, because 4 minus 4 is 0. So those are our critical numbers. Now we'll create a number line, and we'll put the two critical numbers on this number line. And that number line gets divided into 3 regions. And I need to pick a test point on each one of these regions. So a test point here would be any number less than 2. I'm going to choose x equals 0. For the next interval, I'm going to pick a number in between 2 and 4. And it seems like x equals 3 is a logical choice. And finally, I need to pick a number greater than 4, and I'll go with 12. Now we have to test each one of our test points. So when x equals 0, you plug that in, you get 0 minus 2 times 0 minus 4 is less than 0. This says negative 2 times negative 4 is less than 0. And this is false, because negative 2 times negative 4 is positive 8, right? And positive 8 is not less than 0. Next test number, x equals 3. If we plug in 3, we get 3 minus 2 times 3 minus 4 is less than 0. This says 1 times negative 1 is less than 0. And 1 times negative 1 is negative 1. And negative 1 is less than 0. And so this is true. So since 3 gives us a true statement, we're going to shade the interval that x equals 3 represents, which would be all the numbers in between 2 and 4. Now finally, let's check our last test point, which is x equals 12. So we get 12 minus 2 times 12 minus 4 is less than 0. This says 10 times 8 is less than 0, which says that 80 is less than 0. And this is false. And so we will not be shading our last interval here. So the only solutions are the numbers in between 2 and 4. And this time, there's no equal sign, so we will not be including our endpoints. So our solution here is all the numbers in between 2 and 4. And again, we like to write our solutions in interval notation. So our next example is an example of a rational inequality. Rational just means we have a rational function here. Notice that we do have 0 on the other side. This is good. We always want to have 0 on the other side when solving nonlinear inequalities. So my first step here is that I need to factor the numerator and the denominator of this fraction. So x squared plus x minus 6, when you factor that, you get x plus 3 times x minus 2. And the denominator is x minus 5, which of course is already factored. And this is greater than or equal to 0. Next, we need to identify our critical numbers. And the critical numbers are all the numbers that make each of the factors equal 0. So negative 3 is a critical number, positive 2 is a critical number, and positive 5 is a critical number. So negative 3, 2, and 5 are our critical numbers. And then we proceed just like we did in the previous examples. I'm going to draw a number line, putting each one of our critical numbers in order on this number line. And then we need to choose test points. And so everything is exactly the same. I'm going to choose x equals negative 10, x equals 0, x equals 4, and x equals positive 10. And then we need to test. So starting with our smallest test number, which is negative 10, I'm going to plug that into our factored form of the inequality. So when we plug in negative 10, we get negative 10 plus 3 times negative 10 minus 2 divided by negative 10 minus 5, and we want to know, is this greater than or equal to 0? Do the math. Negative 10 plus 3 is negative 7. Negative 10 minus 2 is negative 12. And negative 10 minus 5 is negative 15. Is this greater than or equal to 0? Well, if you multiply two negative numbers, you get a positive number. And then when you take this positive number and divide by this negative number, this is going to be negative. This whole thing here will be negative. It's not important what the actual number is. It only matters that it's negative. So what we're saying is that this negative number is greater than 0. And this is false. So we will not be shading in this interval because negative 10 does not work. Then we plug in x equals 0. This is our next critical number here. We're testing this interval now. So if we plug in 0, we get 0 plus 3, 0 minus 2, and then 0 minus 5. Is this greater than or equal to 0? Well, this says 3 times negative 2 divided by negative 5 is greater than or equal to 0. This is true. And it's true because a negative number divided by a negative number is a positive number, and a positive number is greater than 0. So because x equals 0 is true, we're going to shade in all the numbers that x equals 0 represents, which would be all the numbers in between negative 3 and positive 2. Okay, we just have a couple more to test here. So next we will test x equals 4, which is testing this interval. So if we plug in x equals 4, that's going to give us 4 plus 3 times 4 minus 2 divided by 4 minus 5, greater than or equal to 0. Do the math. This is 7 times 2 divided by negative 1 is greater than or equal to 0. This is false. And it is false because a positive number divided by a negative number is negative, and a negative number is not greater than 0. So we will not be shading in this interval. So finally, we're going to check x equals positive 10. Plug in positive 10. Do the math here. So 10 plus 3 is 13, 10 minus 2 is 8, and 10 minus 5 is 5. Is that greater than 0? Yes, this is true. And it's true because if you multiply and divide a bunch of positive numbers, you get a positive number. And a positive number is greater than 0. So we will shade the interval that x equals 10 represents, and the interval that it represents is all the numbers greater than 5. So now we need to write our final answer here, our solution. Well, we can see here the solution is all the numbers in between negative 3 and positive 2, and we are including, so we'll take everything from negative 3 up to positive 2. Union, we will also take all numbers from 5 to infinity. And we want to include 5 because we have an equal sign here. However, we cannot include 5, okay? We cannot include 5 because if you put 5 into the original, 5 minus 5 is 0. We are dividing by 0. So that's a little bit tricky, but we cannot include 5. And so here is our solution. Now for our final example, we have once again a rational inequality. We have a fraction here. And the first concern is that we do not have 0 on the right-hand side. And so the first thing we need to do is subtract 2 from both sides to get 0. So that gives us 5 over x minus 2 is greater than or equal to 0. And remember, 2 is the same as 2 over 1. So the first thing we need to do is we need to combine these two fractions together. And we can do that by getting a common denominator. And the least common denominator between x and 1 is x. So I'm going to multiply the top and bottom here by x. And this gives us 5 over x minus 2x over x is greater than or equal to 0. And that gives us 5 minus 2x over x is greater than or equal to 0. So now we have what we want. We have a single fraction, and we have 0 on the other side. So now we would factor the numerator and the denominator. However, 5 minus 2x does not factor, and of course neither does x. So the next step is we need our critical numbers. And the critical numbers are the numbers that make each of the numerator and denominator equal to 0. So obviously x equals 0 is a critical number because that will make this factor 0. And then what makes this factor 0? You might have to solve an equation for that. So if 5 minus 2x equals 0, this is the same as 5 equals 2x. Or if we divide by 2, x would be 5 halves. And so this is our other critical number. Now from there, we make our number line. We only have 2 critical numbers. Put them on the number line in order. Pick your test points. So what's a number between 0 and 5 halves? Well, 5 halves is 2.5. So I'll just pick x equals 1. And a number greater than 2.5, I'll just pick 10. Okay. Then you test. Now the testing works the same way. You just plug those numbers into, I would plug them into here. It's the easiest place to test it. And so when you plug in negative 10, you get 5 minus 2 times negative 10 divided by negative 10. This is 5 plus 20 divided by negative 10, which is 25 divided by negative 10. Is this greater than or equal to 0? No, this is false. It's not greater than or equal to 0. So we will not be shading in this interval. Plug in x equals 1, we get 5 minus 2 times 1 divided by 1. This is 3 divided by 1. Is that greater than or equal to 0? Yes, this is true. So we will shade in the interval that x equals 1 represents, which is the numbers in between 0 and 5 halves. And finally, if x equals positive 10, we get 5 minus 2 times positive 10 divided by 10. This is 5 take away 20, which is negative 15 divided by 10. Is that greater than or equal to 0? No, that's false. It's not greater than or equal to 0. And so again, we will not be shading in this interval. And so in the end, the only numbers that work are the numbers in between 0 and 5 halves. And we have equals here, so we want to include both endpoints. However, we cannot include 0, because if you actually put the number 0 into your problem here, you are dividing by 0. And so that is no good. So our solution is all the numbers between 0 and 5 halves. We will include 5 halves, but we will not include 0. All right, time to get to work.